Iterators are everywhere. They're one of the most common patterns used by frameworks to traverse their collection. Yet, even though it's very common, I don't see it used that much in custom code anymore. By which I mean that the frameworks we use tend to already have the iterators in place we commonly need. Its intent is to provide a way to access the elements of an aggregate object sequentially without exposing its underlying representation. Sounds a bit complicated maybe, but simply change aggregate object to enumerable or array or collection, and the intent all of a sudden becomes a lot more tangible. Whenever we use a for each statement over an enumerable, say a list of string, it's an iterator that is used to provide the correct previous or next item. And let's continue with that list example. A list is an aggregate object which aggregates a set of variables, potentially other objects. Lists, but also other aggregate objects like collections, dictionaries, stacks, queues, and so on, keep their items in an internal structure. You don't want to expose this internal structure to avoid it being tampered with in unintended ways. Also, you might not always want to traverse the aggregate object in the same way. You might want to allow traversing it alphabetically or in reverse order. And you don't want to bloat the aggregate object interface with all these different ways of traversing it. And that is what the iterator solves. It takes the responsibility for traversing out of the aggregate list object and puts it in an iterator object. Now, as mentioned, most common iterators on the collections we use already exist. So as an example, we're going to create a custom collection, a collection of people. On it, we're going to create an iterator that iterates over these people, but it's going to do that in alphabetical order by the person's name. We will name our custom collection People Collection. On it, common methods like you'd expect on a collection exist, like add, remove, maybe count, and so on. Next to that, it should also have a create iterator method. That will return our iterator and will define the need for such a method on an interface, iPeopleCollection. So, the iPeopleCollection interface will define an interface for creating an iterator object. We'll name that iPeopleIterator. That too is an interface. Like this, we avoid having to use concrete implementations on our people collection, which means we can easily provide multiple different iterators without having to change the class. The people iterator interface contains 4 methods. First, next, is done, and current item. These are the methods required for iterating over a collection. The last part of the story is the concrete implementation of the iterator, the people iterator. It implements the iPeopleIterator interface, and it will contain the actual logic for iterating over our people collection, sorted alphabetically by name. Let's map this to the pattern structure.